Hi everyone, welcome to the second part of Emacs Berlin. This month I have prepared a talk for you called Emacs and Clojure, a Lispy love affair. So it's sort of going to be a high-up level overview of all the stuff that's either built-in or pre-existing for Emacs that you can use with Clojure, and all the Clojure-specific tools that are available. Just kind of see what a nice match and what a nice ecosystem around that exists. Real short about me, my name is Arne. I make videos about Clojure. They're really cool. You can check them out on lambaisland.com and subscribe if you like what you see. This is my job. This is what I do for a living, so I can use all the support I can get. A small formula, a small logical deduction. So L being the set of all Lisps, then Clojure is a member of that set, so Clojure is a Lisp. This is a logical AND, so Clojure is a Lisp, and Emacs loves Lisps. That's also an axiom. So from that follows that Emacs loves Clojure. That's pretty clear, I believe. So, just the fact that it's a Lisp, you get all this stuff for free. So if you ever think of inventing your own programming language, make it a Lisp, and basically you already have this amazing editor that just works with it flawlessly. Paulo's already talked about structural editing, paredit, smart parents, parinfer, so I don't have to talk about that anymore. That's cool. There's rainbow delimiters. It's a small thing, but it's so great. So what that basically means is that if you have, nested parameters, nested parentheses, that they get, it's not super clear, I guess, with this color scheme, but each pair has their own color. So you can sort of see from a distance which one goes where. Also, I guess it doesn't do it. I'll show you later. If it's unbalanced, then it shows you as well. That's rainbow delimiters. There's inferior Lisp, which is a thing that comes bundled with Emacs for dealing with Lisp wrappers, basically. Whenever you have a process that can read expressions from standard input and will write the result from evaluating that expression to standard output, then you can hook that up with inferior Lisp mode and use that to evaluate stuff from Emacs. Then there's two, I put them sort of separately because they're not really Lisp specific, but the Clojure mode README recommends enabling them. So one is aggressive indent mode. So what that basically does is, whenever you're doing stuff, it just automatically indent it correctly, which is kind of nice. And if I was doing something like Ruby, I would probably not want this because sometimes I care about indenting things in a particular way. But with Clojure, I would pretty much always be happy with automatic indenting. So I think I will leave this enabled. The other one, subword mode, is when you have things that are camel case. So you can use meta B or meta F to go back and forth a word normally. If you enable this subword mode, it's a minor mode, then it'll use individual words inside the camel case instead of treating it as one big thing. Now in Clojure you don't usually use a lot of camel case except when you're doing interop. So if you're doing Java or JavaScript interop, it is very common to have a lot of the camel case stuff there, and then that might be useful. So that's already stuff you get for free. And then there's Clojure specific stuff. So there's Clojure mode, there's Enclosure, there's Cider, and there's CLJ refactor. And I'm going to talk about each of these a bit. So Clojure mode is, like the way that you have Emacs Lisp mode or Ruby mode. It's your typical programming language major mode. But it has some cool features, which I'll talk about. Enclosure is the alternative to inf Lisp, inferior Lisp. So I said, okay, Emacs has this thing built in for dealing with a REPL. But someone was so helpful to sort of make a derived version of that specifically for Clojure that has some Clojure specific functionality of its own. I'll talk about that as well later. And then there's Cider. So, you know, these two, you basically pick one. If you kind of want sort of minimal integration with Clojure, just something that's conceptually simple, so you know that it always works, and that you don't have too many setup problems with it. Enclosure is sort of a very reliable, very basic integration. Whereas Cider is the opposite. Cider is everything but the kitchen sink. It's amazing all the stuff it can do. I'll demo it a bit later on. But so it also introduces more complexity. So that's sort of the trade-off you make. And then finally, there's CLJ Refactor, which has all these Clojure-specific smart refactorings, some of them very cool and impressive. So I hope to demo a bit of that as well. So Clojure mode, well, like I said, it's a major mode for a specific programming language, in this case Clojure. So it does stuff like font blocking. You saw that already, that you get syntax highlighting. I guess would be the modern phrase for this. Emacs calls it font blocking. Indentation. So Lisps are super easy to parse, but they're super hard to format. Because everything's kind of the same, right? Like everything's a list. But if you have this defn, then there's kind of different rules for how, what follows needs to be formatted and indented than if you have a let or something else. So this can get quite complex, and so this is one of the things that Clojure mode provides. Navigation, so things like jumping to the definition of a function. It also, actually jump to the definition, that's something from Cider. I'm getting ahead of myself. The navigation things that Clojure mode provides are actually not that much, but they're useful. They're kind of extensions to what Parity provides. So if you have something like this, so this is, Clojure calls this a vector. Make it a bit bigger still. So this is a vector, and this thing here is metadata. So it kind of goes together with the vector. And so normally with Parity you would jump over each individually, but Clojure has a variant called Clojure forward logical as expression, which jumps over this whole thing. Similarly, you have forms like these. Same thing, because that's really kind of one form, even though you can write it with a space in between. So that's for navigation. And then finally, refactoring. I'll talk more about refactoring in the end. Now, Clojure, there's regular Clojure, there's Clojure script. You can also have files that can be used either from Clojure or from Clojure script. So Clojure is a variant that runs on the JVM on Java. Clojure script is based on JavaScript, runs on a JavaScript runtime. So they're subtly different, and you kind of need to choose, if you make a source file, which one it's going to be. Or you can say, okay, I'll go CLJC, then it can be consumed by either, but then you have to also take care of specific things. But so Cider, or Clojure mode at least, has these 4 different modes that all derive from the basic Clojure mode, so that have specific functionality for each. The font locking in Clojure mode, so the syntax highlighting, is pretty basic. There's an extra font locking file that you can include that does extra font locking, so it has font locking for built-ins. But the thing is that if you use Cider, then it actually connects to a JVM process, and it can inspect the running process, and so it knows exactly, what's a function, what's a macro, what's a built-in, and it can do very exact, much better font locking. About the indentation, so there's a couple different styles that you can set. The difference is to always align, and I just leave it to that. But the thing is, if you start introducing macros, then sometimes things don't align the way that you would like to. So to give you an example here, this is something from a web library called Enclosure. So this get here, this is kind of a special form that says, okay, if someone browses to this kind of route, this kind of URL, then pull out the ID, and then this is kind of like a function body. Everything that follows after that is just regular code. So I really don't want this to align with that first parameter. They're different things. Like these first two parameters are kind of special, and all the things that follow all go together as code. So I really want it to align like this. And so I can say put Clojure indent for get is 2. This 2 means that there are 2 special forms after the symbol. So this is a simple example, but it can get much more complex. So instead of putting a lot of put Clojure indent, you can define them all together with define Clojure indent. You can sort of define them in bulk. And so, for instance, for a def record, to give you an example, it also has 2. The first 2 forms after def record are special. They need to be formatted as just any regular form. And then after that, each thing needs to be indented. After that, each list that follows, the first thing is special, and so the next thing needs to be indented. So it's really, you can sort of specify this nested consecutive indenting rules. Don't worry about the details, just to give you an idea of how complex this gets. But it's cool that it does all that and it does it well. Yeah, and then a final thing that I just sort of found out today reading through this stuff is that it can, if you have a map like this, then with Ctrl+C space, you can have this all aligned, and there's even a variable that you can set to do that automatically. It's not something that I would always use. I mean, I've seen these arguments in both directions many times. The main argument against this is that it messes up your diffs. But it does help readability, so you can sort of decide for yourself if that's something you want. So that's Clojure mode. Now, what's cool about using Emacs for doing Clojure, for doing any kind of Lisp, is that Lisp is really intended to be a programming language that you very, very dynamically, very interactively use. So you typically will boot up a REPL or some kind of process, and then you can use that for experimentation. You code a little, you see what the result is, you code a little more, you can do all kinds of cool stuff. And so in the beginning there was nothing particular for Clojure, so Rich Hickey, the person who came up with Clojure, just used inferior Lisp, which is built in to Emacs. And so you set a certain variable, you say this is the command line invocation to start my Lisp REPL, and then you can, from a Lisp buffer, you can say, okay, now boot up my Lisp REPL, and then you can send forms to the REPL. And then, like I said, there's Enclosure now, which kind of does the same thing for Clojure, so I'll give you an example of that. So in this case, I have, so this is how you would do it for inferior Lisp. Say that I wanted to use the Lumo REPL, which is a ClojureScript REPL, and then you need to set up a couple keys to evaluate stuff. Or you can say, I'm going to use Enclosure. So in this case, I'm going to use Plank. I need to tell Plank to use a dumb terminal, because otherwise it does all kinds of escape codes and it confuses Emacs. So just treat it as a dumb terminal. And then in my Clojure buffer, actually this should be in Clojure minor mode, I believe. Is that correct? Enable this minor mode that contains a bunch of bindings. So now, if I go to my ClojureScript REPL where I have this enabled, I can say Ctrl+C, Ctrl+Z, and it'll boot up a REPL. Or if it's already booted, it will switch to it. And actually, I'm going to close this REPL now. So I just killed this buffer, killed the process. Control C, Control Z. This is something that's really cool with these new Clojure script REPLs. It basically, you know, as soon as I wanted it, it was there. It booted up, it's ready. And so how it works then is you can have a form, you say Control X, Control E, and then it sends that form to the REPL, and so you see the result pop up here. The result is 2. So it is kind of, you know, you need to keep these two next to each other. You're working in a buffer, but at the same time you're kind of switching back to the REPL. It's not always super handy, but like I said, it's simple, it works well. So in your buffer you have this Enclosure minor mode that then gives you the necessary bindings, like Control X, Control E to evaluate a form. Why would you use Enclosure and not just inferior Lisp? Because of this extra stuff. So for instance, I can say Enclosure macro expand, and then here it shows me the macro expanded version of what I was looking at. So you get some Clojure specific functionality. Not all of these work with Clojure script though, I just found out. Hopefully that gets fixed soon. Okay, then we get to Cider. So Cider is kind of the other end of the spectrum, right? Like where Enclosure is very easy to reason about. You have a process, standard in, standard out. You send stuff, you get stuff back. That's it. Cider is based on nREPL. Now nREPL is, it says REPL in the name, but really it's a sort of RPC server. So it's a thing that runs inside your running Clojure process, and it takes messages. You connect to it over TCP, and you send it messages. They're encoded in a specific way. It's called BNcode. I think it's originally from the, torrent, BitTorrent first came up with this BNcode. It's some kind of binary way to encode things. Do I not have my buffer with Cider messages? Maybe not. No, I guess, otherwise I could show you some examples of those messages. But basically you would send a message like, evaluate this thing. But you could also have specific messages, find me all the namespaces where this symbol is defined. So you can have these extra functionality specifically for your editor. And that's kind of how Cider does it. So it's a plugin on top of nREPL that then creates this extra functionality. And then there's a part that runs in Emacs that communicates with that process. And then depending on what you want to do, send stuff back and forth, gets the information it needs. So what do we have in there? Well, like I said, stuff like navigating to the definition of a function and navigating back. Or for instance, if I'm here, this is a file with tests, then I can say Cider test run ns test. So run all the tests in this namespace. So in this case, they're green. So that's good, but let's break a test. And now let's run them again. Okay, so test failed. I get this nice report saying what exactly failed. And now I fix the test, and I go back here and I press F. Yes?
Does it work with media or just Clojure test?
It should work. So Clojure basically has some basic rules about how tests need to be hooked up to vars using metadata. And so any testing framework should be able to plug into that. So I'm assuming that Media uses the same standard, and then it should just work. So I press F, and then it reruns all the failed tests, and we're all good. You also have some stuff to toggle between the test and the implementation. I'm not sure what it's called. Yeah. So that's cool. You also get a debugger, which is a lot of fun. So let me put the implementation. So now on the right are the tests, and on the left is the implementation. So for instance, I have this parse function here So I can evaluate it with Control X, Control E. But if I give a prefix argument, I say Control U, Control X, Control E. No, sorry, I say, if I give a prefix argument to Control U, to Control X, Control E, then it inserts the result in the buffer. That's why this thing just showed up. If I give a prefix argument to Control Meta X, which also evaluates it, then you can see that this parse, yeah, it's kind of hard to see on the screen there probably, but there's a bit of a red square around it now, which means that this function is instrumented. So now I'm just going to run some code that uses that parse. And now I'm here in my debugger. So the thing that you see here is the current value of URI. And you'll see as I step through code that it always shows me the value of the last thing that was evaluated. So you can step through code, you can inspect things, yeah, all the typical debugger stuff, or just say continue and then we're done. So that's cool, and that's just sort of tip of the iceberg for Cider. So I showed you job to definition. Yeah, you can imagine code completion. I showed you the test. I showed you the debugger. Now, one of the interesting things with Cider is that, so it's quite common. I have this project here that I'm doing both Clojure and ClojureScript. So I have a single project, and I also ideally want to have just a single process because running lots of JVMs is expensive. But that process is both in charge of running my Clojure code and compiling my ClojureScript code. And then you would need some JavaScript environment to evaluate that ClojureScript code. So Cider, I'm going to close my Cider REPL again and say cider-jack in ClojureScript. So there's two commands here, cider-jack in and cider-jack in ClojureScript. Both of these will start an nREPL process, connect to it, but the second one will do that and then create two buffers with two different REPLs, one for Clojure and one for ClojureScript. And so depending on which file you're in, it'll send it to the right REPL, and you can kind of do both at the same time. Now, how can it do this, right? Because you need some kind of JavaScript environment. So by default, it would use a JavaScript engine that comes with the JVM, but you can configure how it basically, you need to give it a bit of Clojure code that turns a regular Clojure REPL into a ClojureScript REPL. And do I have that here as well? Maybe, yeah, here it is. So for instance, I'm using this tool called Pinwheel. Pinwheel is something that watches your code for changes and then automatically serves those back to the browser. But at the same time, it also establishes a link with the browser, so you get a REPL, and if you put stuff in there, then that code gets sent to the browser to be evaluated. So you really get this sort of interactive development against your app running in a browser, which is super cool. So here we are. So you see we have two buffers. This is my Clojure buffer. This is my ClojureScript buffer. Here I have a REPL prompt. Here I don't, because Pinwheel is waiting for me to connect. So I'm going to do that. Yeah, I have my localhost alias to lol. Yeah, I clearly broke some stuff in my layout, but that's not the point. Now I got a REPL. Now I'll go to a CLJS file, and now I can do something like JS alert hello and evaluate that. And if all goes well, yeah, I'm probably not. Oh no, I'm using Cider. What does my REPL say? Okay.
This is center inferior.
Blank.
Yeah, I listened to the wrong one. That's true. Oh no, I'm doing it all wrong. Okay. Normally you would have seen a pop-up here. I'm not gonna torture you by redoing that all. But one cool thing is that depending on which project you're doing, you might want to have different environments for your JavaScript. So you can use this dir locals which is just an Emacs thing. So you create in the root of your directory, you create a file called dir locals, and you can configure variables in there that will be set in every buffer underneath that directory. So this is how, in this project, I'm using a different way to boot up my app and to boot up my ClojureScript REPL, and so I have that configured there. The thing is, this is very cool, but it's currently broken. So in the latest version of Cider, this does not work, because somehow it loses the scope, and so by the time it gets to looking for Cider CSS line REPL, it's no longer, so this is a buffer local variable if you do it this way, and it's evaluating it, it's looking for it in the wrong buffer. Finally, there's CLJ refactor. Now, I'm already a bit over time. Let me maybe just show you one or two refactorings.
But I'm interested in this, so if you can continue, I think you agree. It's okay.
That's okay.
Okay, well, I guess I can take a few more minutes. So CLJ refactor started out, so Magnus Finn, which is a pretty well-known guy in the Emacs community. He does the Emacs Rocks YouTube videos, did some popular libraries like Dash, I believe. And so he originally wrote cljrefactor.l, so a pure Emacs Lisp version to do various refactorings. So, for instance, some of the things that it could do, or that it can do, say you have it's a thing in Lisp, right, where after a while you get this like deeply nested function calls, and it's not really a pleasure to read or to. I mean, in this case, it's very trivial, but maybe there's like there might be more parameters here and then another one there, right? How can you sort of make that a bit nicer? So the Emacs way would be to use a threading macro, which makes it look like this. So all the refactorings have a two-letter mnemonic. So in this case, it's TF for thread first. And then you need to decide what your prefix key is. It doesn't by default come with a prefix key. I think it does suggest one. In my case, my right control is bound to hyper, which does not have any pre-existing bindings in Emacs, so it's kind of a whole space that I can define for myself. So hyper M in my case is the prefix for these refactorings. So I will say hyper M TF or thread first, and then I get this. There's also thread last, which is the other threading macro, which in this case is less useful. Another one that I use a lot is add to project, AP. So this is, you're developing whatever code and you need to add a library. Say I want to add SpiceRec, which is a library from Jack Russer who spoke here last month. So I get completion of all the libraries on Clojures and a selection of libraries on Maven Central, because the most Clojure stuff is on the Clojures repository, but the Cognitect stuff is usually on Maven. So it pulls in like stuff like Transit and Clojure itself, that also has that. Then it gives me the list of all the versions for SpiceRec, so I don't need to go Google the README to know what the current version is. Say, okay, I want this one, the latest one, and now when you look at my project.clj, it's been added there as a dependency. Not only has it been added there, but it also gets hot loaded into the current process, which is kind of a benefit that you wouldn't have if you did it manually. Yes?
If I use lining and it works, hot loading or only with boot?
It's lining, right?
You use lining, yeah, I'm using lining.
Oh, so it works with lining and boot.
Yeah.
Hot loading of
Yeah.
libraries. Cool. I didn't know that.
Yeah, so Cider does that, for you. You don't really need to worry about that. Another thing that I use a lot is add missing functions. So in Clojure, you need to import stuff in your namespace that you're going to use. So let's say, well, I guess, what's a Clojure function that's not in core? Or
something with strings.
well, or I guess, like, say I want to do some composure stuff, the stuff that I was showing earlier. So if I try to evaluate this, it tells me that it can't resolve get. It doesn't know what get is, so I need to include get. So I say my refactoring prefix am for add missing, and now, yeah, this comment kind of makes it less clear, but now it added this. It got confused by the comments. Let me do that again. No, this one. Yeah, that looks better. So it added the require statement. This is really cool, and I use it all the time because I'm too lazy to look up what namespaces things are in. The only super annoying thing with this is that it only knows about vars, about symbols that are already loaded. So it's not because something is in a jar on the class path that it's loaded. And so, say I just added spicerec. What's part of the? Yeah, of course, spicerec. Okay, so I should have, for instance, an open database function, and it just got hot loaded, so it's on my class. Okay, and it does know about that one. But yeah, so sometimes you just add a library and it doesn't find it. Kind of annoying. So those are things that I use a lot. Other cool things are, let's change this a bit. Yeah, so I'm using a lot of Power Edit stuff there. So this, for instance, was a splice backwards, I guess. Is that correct? Or I'm actually, it's good advice to know the words, but I don't for a lot of them. I just kind of know how I do them. But so, okay, this is like, assume that this is complicated code and there's some intermediate values there, and I want to make that a bit more clear. So I can say introduce let, and now I can give this a name. This is value x. Okay, but this also looks funny. What I really want is to expand that let, el, to have it there. So that's something useful. And now maybe I actually want to extract this as a function, which, calculate foo. So that's ef, extract function. Or say that I have something like this, so I'm kind of getting ahead of myself. I know that I want a hello function, but hello is not defined yet. Then you can say fe from example. Yeah, I was in the wrong scope, I guess. This is not one I use a lot. I need to do it over here. So from example, and then it introduces that hello function. So these are some of the ones I use. Paulus, do you have specific ones that I should be adding? There's also one to move functions around, or to rename stuff and sort of keep references up to date and keep your namespace declarations up to date. That's useful. Clean NS, clean. So sometimes after a while you get, you've been deleting stuff, but there's still stuff in your namespace declaration that you're no longer using, and you can sort of clean it up and just leave the stuff that's left. I think those are the main interesting ones. I think, yeah.
Are you using now Cider refactor or Clojure refactor functions? Like what?
Yeah. So the thing is, there's CLJ refactor, and that's kind of the top level project, and that's where all these refactoring started. And like I said, originally those were all written in eLisp. Then later on, CLJ refactor got split into two projects. CLJ refactor, which is the Emacs part, the eLisp part, and refactor and REPL, which, as I explained before, the way that Cider also does it adds some stuff to this RPC server to be able to make those calls so that it can use the Clojure analyzer and actually sort of offload some of that more difficult refactoring work to Clojure. So certain things are pure eLisp, certain things are Clojure. The pure eLisp things are being moved, and it seems like most of them already are, all moved into Clojure mode. So even if you're not using CLJ refactor, if you're just using Clojure mode, you can do most of these simpler refactorings like thread first, I think also introduce let, anything that doesn't really require deep analyzing of the code, you can do always in regular Clojure mode. Yes?
Well, the last time I tried CLJ refactor, it was like more than a year ago, maybe even 2 years ago. At that time, it didn't work for me well. I don't know whether it was some discrepancy with Cider or so, but it didn't. So since then, I haven't tried it because, well, the usual paredit was useful enough that I didn't need this extra stuff. But now, when I see it and I follow it on the internet, it seems that it works better. So the question is, if I have, let's say, the last version of Cider or the last snapshot of Cider, what should I expect? Is everything there, or I should specifically, explicitly add some Clojure or Emacs package for this to work?
So the basic refactorings will already be there. Just the fact that you have Clojure mode, you can do thread first, introduce let, a whole bunch of those will already be there. If you want the things like add to project, add missing, move across namespaces, rename a variable like across namespaces, then you need CLJ refactor.
To add it explicitly as an
Yes.
eLisp package.
So you see
With
this is my Clojure setup. So I'm basically sort of the top level thing, the thing that you will always need is Clojure mode. And then I'm also enabling the YA snippet and the subgroup mode, paredit, rainbow delimiters, aggressive indent, and then Cider. And then on top of Cider, I'm adding this CLJ refactor. So they're separate packages, and if you have them both installed, then doing a Cider, so if you go to my messages buffer, this here, let me copy that and make that a bit bigger. This is basically the whole command line invocation that Cider is using to boot the process. And so what's interesting here is that you can see that Cider is injecting itself as a plugin. And also this refactor and REPL is being injected as a plugin. So this does make your startup slower of your REPL.
I don't mind because I start once in a month and then just go to suspend mode. So,
Yeah.
so
I mean, you need to, like, it is a separate package. If you want everything, you need to install it separately. Give it a try, see how well it works for you. It definitely has its problems. I personally fixed a couple bugs in there, like for instance, this add missing would just give would basically block and then time out if you had too much stuff on your class path. And the reason that it would time out is that there would be an error on the Clojure side, but it would not be reported back to Emacs, and so Emacs would just sit there waiting idly, and then at the end say, oh, it seems like it timed out. And this kind of stuff is extremely frustrating, because it's not working, you're waiting for it, in the end it's saying it didn't work, and you get no useful feedback. But so that's fixed. I also contributed a small patch which means that in general, when any kind of problem happens on the refactor and REPL side, that it should get reported, so at least you should get a message in Emacs. Another bug I fixed, I fixed something else in there. The thing that I use a lot is this add missing, right? And so if this isn't working, then basically I drop everything and I try to fix it because I've become so reliant on it.
no, at that time nothing worked for me,
Yeah.
for myself. But now I don't mind. I'm not frustrated if something is not working or if there is some problem. So I don't mind that. But I'm satisfied that now basically I don't have to do much manual setup. it works in a package and lots of functionalities there. We use 2% probably, like in Emacs usually.
Exactly. You start with the one or two that you find useful and can remember, and then maybe 3 months later you look at the README again and learn one or two more. It's kind of how I do it. Okay, let's call it there, because I'm already taking a very long time, and we still have a lightning talk and maybe more lightning talks. So maybe if anyone has one last question, yes.
You added a get function and open the database function on the fly to require. If we have a same function in two different packages, what will happen? Just is it gonna be some pop up?
Yes, you get the choice. It'll tell you which one do you want.
All right, I like it.
Yeah.
Okay.
So I think maybe read exists in multiple namespaces. Yeah, a whole bunch of namespaces, so you can choose which one you want.
All right. Thank you.
Okay, thanks. Yeah.